Hey everyone, welcome to the 5.1 notes. In this section, we're going to be comparing linear and exponential. So, this one is going to be linear because there's no exponent. So, hopefully, it kind of makes sense to you just because of common sense that an exponential would have to have an exponent. Okay. One other thing before I go into this first question, remember that linear has the word line in the beginning of it, meaning that it is supposed to be a straight line. Exponential has the word exponent in front of it, so it has to have an exponent. And what that means on the graph is it's going to go either really quickly up like this, or it's going to go really quickly down like this. So it's not a straight line anymore because it almost goes vertical at the end. It starts going up so fast. So you might have heard rising exponentially or growing exponentially in the news or something, especially about COVID cases. That's what it means is it's starting to go up really fast. Instead of like steadily going up by the same number, it's going up super fast or going down super fast. In an equation, the difference between 2x and x squared, so whether that 2 is in front or an exponent, is this. This is 2 times x. And when we say 2 times x, what we mean is you're taking two x's and adding them together. Over here, x squared means that that's how many times you're multiplying x by itself. So linear adds together and exponential it multiplies together. Okay, same idea over here. 4 times 3 just means you have 3 or 4 threes added together. This one is the linear one. The one with the exponent, instead of 3 plus 3 plus 3 plus 3, it's 3 times 3 times 3 times 3. Okay, so the whole main difference between linear and exponential is that for linear, you're going to be adding the same number each time. For exponential, you're going to be multiplying. Okay, if you're adding, that number is called the common difference. If you're multiplying, it's called a common ratio. And what we're going to do is come look at these tables and determine if it's linear or exponential and list the common ratio or difference. Then it also says growth or decay. These are a little more straightforward. Growth just means the values are going up. So if they're getting higher, decay means the numbers are getting lower or are decreasing. And initial value means what it always means, and that's the y-intercept. Okay, so the initial value is where it starts. Initial means like the start. And all of these tables are going to start with x equals 0. So notice how all of these go 0, 1, 2, 3, 0, 1, 2, 3, 0, 1, 2, 3. And even in the bottom, 0, 1, 2, 3, 0, 1, 2, 3, 0, 1, 2, 3. And I'm going to keep that pretty consistent for this section. So, linear or exponential, growth or decay, and then by how much is basically what this is saying. Okay, so over here in this first one, we go from 1 to 7, 7 to 13, and 13 to 19. And we are going to check to see if we're adding first because that just goes more naturally in our minds. So if I'm going from 1 to 7 by adding, I'm adding 6. If I go from 7 to 13, I'm adding 6 again. If I go from 13 to 19, look at that, I'm adding 6 again. If you find out that it's adding the same number each time, that's linear. Same number is added. So this one's going to be linear. These numbers are going up. 1, 7, 13, 19. So that's growth. Again, we are focusing on the y values because I left the x values the same on every table, so that would make no sense to look at the x's. And then I want you to say by 6 because it's going up by 6. When I come over here to try the second one, technically this would be going down by 60. But this one is only going down by 15. Since those numbers are different, it's not subtracting. Instead, it's got to be multiplying by something. Okay? So your only two options are to add or multiply. Now you might be like, but Mrs. McFadden, this one's dividing because they're getting smaller. And you're right, it is dividing. You could ask yourself, what do you divide 80 by to get 20? That would be 4. But instead of saying that we're dividing by 4, we're going to say that we are multiplying by what's called the reciprocal, which is 1/4. So dividing by 4 and multiplying by 1/4 are the same thing. Just like dividing by 2 and multiplying by a half are the same thing. And then guess what? 20 divided by 4 is 5. And 5 divided by 4 is 1.25. So we're on the right track because it did this the entire way. Since we are multiplying, and I'm going to abbreviate, I'm just going to go with exponential, or instead of writing exponential, I'm going to write exponent. And these numbers are going down, 80, 20, 5, 1.25. So that's decay by 1/4. I'll go box the other one. And then this third one, we go from 5 to 1. So if we were focusing on adding first, that would be adding -4. And then this would be adding -4. And this would be adding -4. Those are all the same. So it is linear. And these numbers are going down, so that'll be linear decay by. And then there's two options you can technically do here. You could just write 4, because the fact that it says decay means that you're going down 4, not up 4. Or you could write by -4. A lot of people will just say that's being redundant or saying the same thing twice because decay is already there. And then you're going to see a couple that ask you to fill in the table using the pattern. It's kind of like giving you directions. So when it says linear decay by -5, that means you're going to be adding -5 each time on the table. And then the initial value of 3 means you're going to start with 3. And then you're going to add -5, which makes that -2. And then you're going to add -5, which makes that -7. And then you're going to add -5 again, which makes -12. And that's it. That's all you have to do for the tables. The next one says exponential growth by 4. That means we're going to multiply by 4 because it's exponential. And exponential means you're multiplying instead of adding. And it has an initial value of -2. -2 times 4 is -8. -8 times 4 is -32. You're probably going to need a calculator for this one, but -32 times 4 is -128. Then it says Mila has 8 followers and gains 12 per day. 8 followers is how much she starts with, so that's going to be where we start our table. And then it says she gains 12 per day. That means you're just adding 12. So if she had 8 the first day, she gains 12, now she has 20. She has 20, she gains 12 more, now she has 32. She has 32, she gains 12, now she has 44. And then we have this last one, which says a store has 800 customers, but they lose half each year. So you're multiplying by a half here. Another way of doing this could be dividing by 2, if that's easier for you. Okay, those are the same thing. 800 divided by 2, or half of 800, is 400. 400 divided by 2 is 200. 200 divided by 2 is 100. And then with these word problems, the whole point of doing this is so that you can predict the future. So if Mila keeps going with this pattern, how many followers will she have in 5 days? Well, I'm at 3, so I need to add 12 two more times. This one will be day 4, this one will be day 5. So I need to do 44 plus 12 plus 12, or 44 plus 24. It ends up being 68. And then over here, how many customers will the store have in 6 years? I'm going to keep going with the table to help you out a little bit. And you can do this anytime you want and just extend your table. Half of 100 is 50. Half of 50 is 25. And half of 25 is 12.5. Now, it's not possible to have 12 and a half customers. So you're going to have to round this. But rounding works a little different in some word problems. Because if you don't have 12 and a half customers, technically that means you just have 12. Because the half doesn't count since you don't have a half customer. I wouldn't round it up to 13 because you don't have 13 customers. You have 12 and a half. Since you can't have half a customer, that technically leaves you with 12, not 13. So I'm not rounding mathematically here. I'm rounding based off of common sense, as I would call